All right. So let's discuss your homework. So yesterday I asked you to do number 2 from exercise 5.2. But before this, let's go back to maybe one question, right? What is the remainder theorem? What is its purpose? So its purpose is for us to find the remainder of a polynomial divided by maybe another expression, right? So for example, like from where we began yesterday, so instead of doing this long division right here, instead we just get the function of the divisor, which is, let's say, x minus 2, and then we just apply functions. Okay, if you still remember the functions topic that we had last year, and then we just substitute in all values of the functions, and then you'll get your remainder right away. So that's the purpose of the remainder theorem. Let's have one question. Probably let's have letter A from number 1. All right, so let's have letter A. So we have this expression, and then it's divided by x plus 1. Again, your function is f of negative 1. All right, I think everyone knows this already, how I got f of negative 1, right? So again, I get that from x plus 1 equals 0. So therefore, x is negative 1. Therefore, your function is negative 1. All right? So um, when you insert f of negative 1, you'll be able to get the remainder of the expression, right? So let's plug in f of negative 1 to this expression. So we substitute all x terms with negative 1, and then that will give us 6. So that means that the remainder of this expression divided by x plus 1 is equal to 6. All right, and yeah, that's it. Okay, so the rest, you just browse this again. Okay, and then let's have your homework, right? Homework number, okay, example, homework number 2. All right, so number 2, you need to find k if x cubed plus 3x squared minus kx plus 4 leaves a remainder of k when divided by x minus 2. All right, let's go here. All right, so here. So here's number 2. My answer is 8. All right, that's the value of k. Now, how do we begin? First is, okay, you identify the function first. The function is x minus 2. That means that you'll have f of 2, right? And then by applying the function f of 2, you will get the remainder r, right? In this case, we also have a value of r, which is what? Which is k. So r is equal to k. So that's why r here became k, because from here, that's your remainder, right? And then this f of 2 will be, okay, this function here will be substituted to this expression here. Okay, so that's the expression given, right? So what do we need to do next? So once you have this expression equals k, you just need to substitute 2 to the x terms, and then you'll have this equals k. All right. Again, this is equals to k because k is your remainder. Okay. And thus simplifying this, you'll get 8 plus 12 minus 2k plus 4. And then combining like terms, so I'll transpose k to the left side. It gives me negative 3k, right? With negative 2k. All right. So, and then adding this, and then transposing it to the right side, it'll give me negative 24, right? So your k is equal to 8. I think you guys know what happened here, right? So we just divided it by 3. That's how I got my value of k. All right. Any question, class, for your homework? Any question, guys? Okay, Hannah, Darren, can you guys start your videos? Okay. I only see Sam and Mario here. Okay, Victoria, you too. Please start your video. All right, so that's for number 2. All right, let me give you one more, or maybe two more examples. All right, so let's have number three. All right, so number three, let me read the question. Is the expression 6x squared minus 2x plus 3 leaves a remainder of 3 when divided by x minus p. Determine the values of p. So let's figure out what to do here on number 3. So first, the remainder is 3, right? And then your divisor is x minus p. So that means if this is your divisor, your function is what? X minus p equals 0, right? So it's x is equal to p. So that means it's f of p. So that is your function, right? And then, of course, the function is equal to the remainder, right? So basically, this r here becomes 3. And then this function here, we need to insert this to the given expression, 6x squared minus 2x plus 3. So that's how I got this equation right here. Okay, so equals 3. Again, why is it equals 3? Because again, the function is equal to the remainder. So the function here will be inserted here equals 3, which is your remainder. All right. And then do take note, right on the question, it says you need to determine the values of p. So values is plural. That means you'll get two answers or two values of p. All right. So yeah, let's simplify this first, right? So basically 3 and 3 equals to 0, right? If I transpose 3 here on the left side, it becomes 3 minus 3, giving me 6p squared minus 2p equals 0. And how do you answer this kind of equation? So you basically just need to find the common factor, which is 2p, because 6 and 2 is divisible by 2, HCF. And then we have p squared and p. So your common factor is 2p, right? So 6p squared divided by 2p, you'll get 3p. And then minus 2p divided by 2p is minus 1. All right, and that equals 0. So therefore, here are your two factors. So once here, so 2p is equal to 0, and then 3p equals to 0. Sorry, 3p minus 1 equals to 0. So therefore, the values of p are 0 and 1/3. Okay, any question, class, for number 3? Hmm? Number 3. All right. All right. So let me have another example. Okay. So from here, I'm going to skip number 4. So later you'll be doing number 4. Okay. This is my maybe second to the last example for today. Okay, maybe. All right. So this one is a bit long. So please listen carefully, class. All right. Um, okay. So basically, uh, from my workings, you can see that I have solved this by simultaneous equations because I have two equations here, right? So how did I get this two, and what's the question about? So let's have number 6. Okay, so for number 6, the expression 8x cubed plus ax squared plus bx minus 9 leaves remainders negative 95 and 3. Class, again, you have two remainders here, negative 95 and 3. When divided by x plus 2 and then 2x minus 3. So basically, class, this question is telling you that this expression here was divided twice, right? It was divided twice by x plus 2 and then 2x minus 3. And these are the remainders for each division, okay? So the question here is we need to calculate the value of a and b. All right. So for my first equation, okay, let me highlight that with maybe red, okay, since I'm using red marker for that one. Okay, wait. All right. Okay. So this is the first equation. It will come from the first division. So again, the expression is divided by x plus 2, and then your remainder is negative 95. For the second equation, highlighted in blue, so you divided the same expression, but this time by 2x minus 3, and your remainder is 3. All right, so from there, you got two equations already. So let's first find the first equation, given this details here. So again, what is your function? If your divisor is x plus 2, that means that your function is f of negative 2. Okay, everyone got this on how I got this one? So again, x plus 2 equals 0. So x is equal to negative 2, right? So therefore, f of negative 2. Okay, so f of negative 2 is equal to negative 95. Why is it equal to negative 95? It's because this is the remainder of that division. Okay, okay, so that's the remainder. So that's why this is your first equation. Now, simplifying this, you need to insert this f of negative 2 back to the expression. That's why I have written the expression again, given here. So what do we need to do next? Of course, functions, right? We need to substitute the x terms by negative 2. That's why it became 8 times negative 2 cubed, a times negative 2 squared, and then b times negative 2, and then minus 9n equals negative 95. All right. So any question, class, on that process? All right. Again, equals 95. This is your remainder. Okay. And then simplifying this, you'll get this line right here. You have minus 64 plus 4a minus 2b minus 9 equals minus 95. So simplifying this, class, I'll get 4a minus 2b equals negative 22. Now, you, you, you can use this equation. Okay, you can stop with this one. Okay, this is your first equation basically. But if you want to make the numbers smaller, this three numbers here, 4, 2, and 22, are all divisible by 2. So again, with that, I made the numbers a bit smaller, so it's manageable for me to solve. Okay, so this is my first equation, class. Okay, so this is my first equation. All right, so that's it. Okay. Okay, so yeah, that's it. My first equation. How about the second equation? So for the second equation, again, this expression is divided again, right? So that's why it's the divisor. The second divisor is 2x minus 3, and then the remainder is 3. So from here, what is the function here? If your expression is 2x minus 3, again, your function will become f of 3 over 2. And how did we get 3 over 2? So basically 2x minus 3 equals 0. So therefore, x is equal to 3 over 2, right? So you transpose 3, you divide it by 2, you get 3 over 2. So therefore, your function is 3 over 2 equals 3. Again, 3 is your remainder, right? So the function equals the remainder. Now, using the same expression, so basically functions, you need to substitute the x terms with 3 over 2, right? So that's why you have 3 over 2's all around. And then equals 3, okay? So simplifying this, you'll get this one, 27 plus 9 over 4a plus 3 halves b minus 9 equals 3. All right, so simplifying this, you'll get this one, okay? So 9 over 4a plus 3 over 2b equals negative 15. So 27 minus 9, and then transpose it here. You get what? Negative 18, right? So you get negative 15. Okay. And then from here, um, basically, class, you can use this as your second equation. this fraction right here. However, I think it will be difficult for me if I keep this fraction. So what I did here, class, that's why this is a bit long, because I don't want to have fractions on my second equation. So what I did is I removed the fractions by combining these two right here. So your LCD is 4, right? So simplifying this fraction here, so 4 divided by 4 times 9 is 9a. 4 divided by 2 is 2 times 3 is 6b equals negative 15. So removing the fraction by cross multiplication, so bring down 9a plus 6b, and then 4 times negative 15 is negative 60. So you can also use this equation as your second one. Okay. However, if you want to make it a bit easier, you can make the numbers a little smaller, because 9, 6, and 60 are all divisible by 3, right? So therefore, this is my second equation. 3a plus 2b equals negative 20. All right, any question, class? All right, so that's your second equation, and this is your first equation. Okay, so what did I do next? Now, basically, this is solvable by simultaneous equations, right? So what I did here is just solve them by substitution method, okay? So by substitution method, what I did here, so this is my second step, or the second part, okay? So because I need to find the values of a and b. So wait, let me just write them together. Okay, so you guys will see. Okay, so here's your first, and here is your second equation. This one. Okay, I'll just move it right here. Okay, so basically, guys, these are your simultaneous equations. Okay, so how would you solve this? You can either use elimination or substitution. It's up to you. For me, I solved it by substitution method. So what I did here is I changed the subject of the first equation. So I changed it to b is equal to 11 plus 2a. All right. And then I'm going to insert this to the second equation. Okay, so that's substitution method, right? So that's what I have here. So this is the second equation. And then instead of b, I'll have 11 plus 2a instead, right? So this is your equation right here. And then solving for a, so remove the brackets, simplify this. So therefore, a is equal to negative 6. All right? And then how do I solve for b? So just use this equation here. Okay? So to solve for b, b is equal to 11 plus 2a. So 11 plus 2 times negative 6. Right? So therefore, b is equal to negative 1. Okay? So question number 4. Let me read the question here. Um, so when x to the power of 4 plus x cubed plus 2ax squared minus 14a to the power of 4 is divided by x plus 2a, the remainder is 32. Find the possible values of a. So let's break down the question again. From here, your divisor is x plus 2a. That means that your function will be f of negative 2a. All right, negative 2a. How did I get f of negative 2a? So x plus 2a, just make it equal to 0. So x is equal to negative 2a. So therefore, your function is negative 2a. That's how I got this. All right. And then the remainder is 32. Remainder is 32. That means this is your r. That's why the function negative 2a is equal to r, or to the remainder. Okay. So r is 32. And then Of course, this is your expression. And then we are looking for the values of A. Again, values is plural. That means we'll have two values of A. Okay, so let's solve this now. All right, so again, the function negative 2A is equal to the remainder. So for us to find the values of A, we need to follow this equation. So again, what is next after this? So using the expression given, all right, we need to substitute all the x terms by negative 2A and then equals the remainder, which is 32. Okay, so once you're here, your next step is to substitute the x terms with negative 2A or minus 2A, and that's how I got this. All right, and after that, simplifying this class, so this one, so negative 2A to the power of 4 becomes 16A to the power of 4, and then this becomes negative 8 cubed, and then this is 8A cubed, and then bring down 14A to the power of 4 and 32. Okay, so basically class, what you need to do next is to combine like terms and rearrange them. All right, okay, so take note class, I have a mistake here. This is supposed to be 4, not 2. Okay, this one. All right, okay, so yeah, correct. Okay, so wait, let me double check my answer. So this is supposed to be a to the power of 4 equals 32, right? So this is supposed to be, yeah, to the power of 4. Yeah, supposed to be to the power of 4. Okay, so this is supposed to be to the power of 4. And then there you go. So, so how do we get rid of this one? Of course, it's the same. So we need to get the, okay, sorry for this one. Okay, so this one, so becomes, we need to get the fourth root of this. Okay, okay. So your answer here is supposed to be positive and negative 2, not 4. Okay, sorry for that. Okay, so anyway, so going back here, so this is 16a to the power of 4 minus 14a to the power of 4 will give you 2a to the power of 4. So this is basically 0, right? So 2a to the power of 4 equals 32. So divide both sides by 2. That's what you need to remove first. So you'll get a to the power of 4 equals 16, right? So basically you need to get rid of the power of 4 by getting the fourth root. Okay, the fourth root of both sides. Okay, so it cancels out the power of 4. So you're left with a. And then you guys know how to answer this in your calculator, right? So fourth root of 16 will give you a positive and negative 2. So that's your answer for number 4. Okay, any question class for number 4? All right, none? Okay. All right, now let's go to number 8. Okay, so number 8 is similar to number 6. Okay, now let me read number 8. Now, the expression x cubed plus ax squared plus 7 leaves a remainder of 2p when divided by x plus 1. And then another remainder, p plus 5 when divided by x minus 2. Calculate the value of a and p. All right, and then what do we need to do first? So we need to, um, basically this is simultaneous equations, right? Um, okay, so this expression here again is divided twice by p plus 5n, sorry, by x plus 1 and x minus 2, right? And these are the remainders for each of them. Now, we need to formulate our first equation and second equation respectively. So for our first equation, our function is this one, x plus 1. So therefore, it's f of negative 1, right? This is our divisor. And then the remainder is 2p. So this is your r, okay? R, okay? You can change this to r, okay? So your r is 2p, okay? So that's how I got this. And then what's next? Of course, using the expression given, you substitute negative 1 to this x terms. That's how I got this. So negative 1 cubed plus 8 times negative 1 squared plus 7 equals 2p. Again, 2p is your remainder. And then simplifying this, you'll get this, and eventually you'll get a minus 2p equals negative 6. So this is your first equation. So this is your first equation. All right. How about our second equation? How did we get here? All right. So for the second equation, let's look at the second divisor, which is x minus 2. Again, if it's x minus 2, your function is f of 2 equals the remainder. So the remainder for this one is p plus 5. That's why function of f of 2 is equal to p plus 5. So using the same expression given, we substitute 2 in place of the x terms. That's how I got this here. And then simplifying this, you'll get 8 plus 4a plus 7 equals p plus 5. And then rearranging this, 4a, and then the transpose p, and then this is 15. Put it here, becomes minus 15. So 5 minus 15 is negative 10. So therefore, this is my second equation. Okay. All right. So we basically have our first and second equation. Okay. So you can solve this either by elimination or by substitution. So it's up to you guys. All right. If you find elimination easier, you can go ahead and use that. All right. So basically, okay, I'll just put them here. Okay. Okay. So here are your two equations. Okay, together. And then for me, I'm going to use substitution method. So what I'll do, I'll change the first equation and make a the subject of the formula or the equation. So it becomes a equals 2p minus 6, just like this. All right. And then what I'm going to do next is to substitute this one in place of a. All right. So that's how I got this. So 4a minus p, right, equals negative 10. So instead of a, you'll now use 2p minus 6 by substitution method. So this is what I got now. And then simplifying this, you'll get 8p minus 24 minus p equals minus 10. So solving for p, so 8 minus 1 is 7p. Transpose it here, you'll get plus 24. So you'll get 7p equals 14. So therefore, p is equal to 2. Okay. And then for the value of a, you'll just use this one. And then you plug in the value of p, which is 2. So a is equal to negative 2 for number 8.